I'm going to compute the integral from 0 to 3 of x squared dx using the definition of integral and not using antiderivatives. First, I want to copy down the definition of a definite integral straight from my notes. This is the same first step every time I do this kind of problem. The next thing I do is I figure out what xi star and delta x are going to be. Delta x is the width of every little rectangle in my Riemann sum. The formula for it is b minus a over n. So b is 3, a is 0, and that means that delta x is 3 over n. Xi star, I personally use the right endpoint of every little subinterval for xi star. I've memorized a formula for xi star. It's a plus I times delta x. That makes things easier for me. So I know that xi star is always going to be I times 3 over n. After I've substituted those two things, I'm going to look at what my function is. F of x is equal to x squared. So that means that f of 3i over n is 3i over n squared. The next thing I have to do is a bunch of algebra. I'm actually going to square 3i over n, and I'm going to collect all three n's that are on the bottom, and I'm also going to collect the 3's. Next, I'm going to use a property of sums. I know that any factor that doesn't have an I in it can be factored out past the sigma. So 27 over n cubed can be moved out in front of the sigma. That's actually because of the distributive property. Next, I know what the sum as I goes from 1 to n of I squared is equal to. I know that it's n times n plus 1 times 2n plus 1 all over 6. So I make that substitution. Everything else I leave alone. Finally, I'm ready to take the limit. I notice that this is a rational expression. The power of the polynomial on top is 3 and the power on the bottom is 3. And so that means I get to take the leading coefficients of the top and the bottom, and that's what the limit is going to be. So I can tell that the leading coefficient in the numerator is 27 times 2, and the leading coefficient of the denominator polynomial is 6. And that means that this limit is exactly equal to 54 over 6, or 9.